Welcome back to another episode, all. Throughout this episode, I'm going to introduce you to the dark side of CRISPR, part of biotechnology which has been discovered in recent years, which is a promising approach for the field of medicine. Let's get started. Altogether, this is about genetic engineering, where CRISPR is able to manipulate by replacing, altering, or editing pieces of DNA. And apparently, CRISPR is cheaper compared to the previous methods which have been used. But this is taking us down on a dangerous path of a second eugenics movement, which is going to, just like the racial eugenics movement in the 20th century. Since diversity is essential for human survival, and if mutations are required in order to generate diversity among genetics of the human race, wouldn't it seem odd that if we kept perfectly replicating our parents, our ancestors, that we would not adapt with the environment? So, do you think it's possible that the mutations which persist have been positively selected throughout evolution, even if we do see them as something bad? So since mutagenesis is meant to occur in order to generate such diversity, I would say whether we like it or not, these mutations are meant to persist. Because all humans are born with mutations, but why do so few of them persist? I'm just going to quote someone called Evelyn Fox Keller. So I quote, Evelyn Fox Keller, Professor of History and Philosophy of Science at MIT, explains, "We now know that mechanisms for enduring genetic stability are a product of evolution, yet a surprising number of mutations, in which at least some of these mechanisms are disabled, have been found in bacteria living under natural conditions. Why do these mutants persist? Is it possible that they provide some selective advantage to the population as a whole? Might the persistence of some mutated genes in a population enhance the adaptability of that population? Apparently so. New mathematical models of bacterial populations in variable environments confirm that, under such conditions, selection favours the fixation of some mutated alleles, and furthermore, that their presence accelerates the pace of evolution." Close quote. So, in this case, the reasons these mutations tend to persist are mutations behind disabilities such as autism, Down syndrome, ADHD, and so on. They persist because they provide an evolutionary advantage, enhance our adaptability to an evolutionary environment, such as our environment's changing through things like pollution, climate change. We're going to have to adapt to it. I'm just going to give an example from recent discovery. I quote, "In Africa, researchers found sickle-shaped red blood cells in people across a broad belt, from Nigeria in West Africa to Tanzania in the east. The cells also turned up at high rates in people in parts of the Near East and India, and in southern European countries such as Greece. Genetically speaking, this made no sense, because inheriting 2 copies of the gene is so deadly. The mutation should have become rarer with passing generations, not more common. In 1954, a South African-born geneticist named Anthony C. Allison observed that people in Uganda who carried a copy of the sickle cell mutation suffered fewer malaria infections than people with normal hemoglobin. Later research confirmed Dr. Allison's finding. The sickle cell mutation seemed to defend against malaria by starving the single-celled parasite that causes the disease. The parasite feeds on hemoglobin, and so it's possible that it can't grow on the sickle cell version of the molecule. Sickle cells are a rare example of human evolution, where we have a good idea of what happened and why, said Bridget Penman, a malaria expert at the University of Warwick in England. Close quote. So that's one example of how what we saw to be a disease, that if we eradicated that, that would actually prevent us from being able to survive. When we look back to the 14th century bubonic plague, it was actually the mutations that have enabled the Europeans to survive the bubonic plague. So these are just a couple of examples throughout history where if we messed with all these mutations which are persisting, that would mean that we wouldn't be here. We would be closer to extinction by weakening the human gene pool. As the more mutations that get eliminated, the weaker the human gene pool becomes, and the less likely we are to survive by reducing the diversity, which is essential. And to take things a bit further, is we now know that mutations can actually build on top of one another to produce new metabolic pathways, which might be an adaptation for what our environment's evolving into through things like pollution. So many diseases that we're seeing now, so many ecological crises that we've experienced, are actually all due to a lot of what humans have done to nature. The direct results, things like AIDS and Lyme disease, that's because of what humans have done to nature. The nature versus nurture is a dichotomy. We are actually part of nature. Our genes are always interacting with the environment, and the environment's always interacting with us. It could be said that the whole earth is just one organism, all connected together. But when you mess with one part of it, it is going to cause a big chain of reactions, and we don't know what damage it could cause, but it could always come back and haunt us by things we don't know. If you are someone who likes to learn, you'll probably know by now that the more you learn, the more questions come up, and the more questions you'll begin to have, the more you'll realise just how little we know about genetics in humans. So this is a very dark path that we're going down, and the scientists behind it in biotechnology are going to have to be very careful. And we are going to have to set ethical standards in place. If you would like to hear more about the dark side of CRISPR, of what dangers it poses upon us, what risk you need to be informed about, hit like, hit subscribe, and you will be informed of any future content when it comes up. Thank you.